Hey everyone, welcome to Ethiopian 16. If you are a new member of my YouTube channel, please share and subscribe Ethiopian 16. On our today's lesson, I'm going to explain how we are going to solve this problem. Is that, look, this is a combination of exponential and logarithmic. And this is an exponential equation. And there is something here, logarithm, and there is also another logarithmic problem. So how we are going to do all these problems in general? Therefore, in order to describe, in order to find, in order to solve all these problems, don't forget to share, like, and subscribe Ethiopian 16 because I have already solved many related problems of this one. Is that? So let's come to the first problem. Look the first problem. How we are going to do this one? Now let me write again this problem with different ways in general. Is that? So in order to find the solution of the first problem, that is 6 raised the logarithm of x to the base 2, which is gonna be x. In what way we just solve this problem? Be careful. Let me show you how to do this one. A problem is given this way. First of all, we have to describe 6 as a product of these two and some other factor. Is that? So 6 can be written as 2 times what? 3. So this is gonna be 2 raised the logarithm of x to the base 2 times 3 raised the logarithm of x to the base 2. That's gonna be x. Is that? This is written in the form of this way. Do you know the reason how this will be described this way? You know that from the law of exponent, AB raised C mean what? A raised C times B raised C. Is that? So because of this principle, 6 mean 2 times 3. So this is the logarithm of x to the base 2 mean 2 raised the logarithm of x to the base 2 times 3 raised the logarithm of x to the base 2. That can be written in the form of this one. So I have written this way. Therefore, with the other laws of logarithm, that means I think you can look my previous video again. I have already explained this principle. What is the b raised the logarithm of x to the base b mean? This is absolutely x. Is that? So if this exponential problem, if the exponent of this base is logarithm and the logarithm of the base and the exponent, the exponential, this is the same. So you can simply make it x. Is that? So because of that principle, this will be cancelled by this one and you can have x times 3 raised the logarithm of x to the base 2. That's gonna be x. Is that? Then how we are going to solve again this one? Now you can divide both sides by x and x cancel by x. 3 is left, raised logarithm of x to the base 2. That's gonna be 1. And you know that at the very beginning, the domain for this is x greater than 0 and the value for x, this can be any real number. That means x can be an element of real number. Then we need to determine the intersection of this one in order to determine the domain. Is that? So the domain will be what? The common of this and this is gonna be, domain will be x is that x is greater than 0. So this is our general domain. Having this domain, now we can solve this problem. And you know that this is an exponential equation. So for this exponential equation, in order to find the value for x, we have to turn this into an equivalent logarithm. So the equivalent logarithmic statement for this is going to be the logarithm of x to the base 2. That's going to be 3 raised to 1. Is that? We have to just do this way. Is it? So log x to the base will be 3 raised to this one. So logarithm of x to the base will be 3. Finally, in order to find the value for x again, we need to find equivalent exponential. Here, it is an exponential. So in order to find x, we need to change this into its equivalent logarithmic. This is the equivalent logarithmic statement for this one. Again, finally, I have already just calculated or found the exponential. This is, now you know that the equivalent logarithmic statement for this is this one. Then we need to just describe the equivalent exponential of this one. So this is gonna be, you have to go this way. 2x will be 2 raised 3, which is going to be 8. So the value for x is 8 because it is greater than 0. So the solution for this problem will be 8. If x is 8, now these 6 raised, these x to the base will be 8. Is that? So this is the value for x. How we are going to determine this logarithmic equation. Is that? Well, now let's come to the second problem. How we are going to do the second problem? In order to determine now the second problem mean what? This one, 2 raised x minus 1, which is 3 mean what? Now this can be written as, this is written as 2 raised x times 2 raised minus 1. That's gonna be 3, is that? And this is simply 2 raised x times 1 over 2, which is going to be 3. Let's multiply both sides by 2. And this implies that 2 raised x will be 6, is that? Then, how we are going to determine the value for x? The value for x will be what? Value for x is going to be x is the logarithm of 6 to the base 2, is that? This is the reason logarithm of x will be, x will be logarithm of 6 to the base 2. So the value for x is going to be this one. Maybe now x is written as the logarithm of 6 will be 2 times 3 to the base 2. And with the law of logarithm, it is going to be logarithm of 2 to the base 2 plus logarithm of 3 to the base 2. And this is going to be 1 plus the logarithm of 3 to the base 2. Is that? And x is simply, this implies x will be 1 plus logarithm of 3 to the base 2. Is that? This is the value for x. This is the way how we are going to find the value for x in the case of the second problem. Is that? So generally, in order to solve any logarithmic problem, you have to remember the law of exponent and logarithm. That means, you know that a logarithm is a mirror image of an exponential, or exponential problems are mirror image of logarithm along some line of reflection. Is that? So this is the way how we are going to solve this problem in general. So now let's come to how we are going to do second problem. On the second problem,